Okay. All right. So. Okay. Oh, okay. All right. Okay. All right. So when we're graphing inequalities in systems, remember that you have to make the decision on whether you have a solid line or a dotted line or a dashed line. Now, what's the difference? How do you know if you have a solid or a dashed line? What can you guys see the difference here? Yeah, there's that equals to underneath it. Make sure that we can tell when you're graphing it whether it's solid or dotted. Then you also have to shade. So you're going to shade above the line when it's y is greater than or y is greater than or equal to. And then you shade below the line when y is less than or equal to. This what it looks like right there, you want to make sure that it's y is or x is, or sorry, y is less than or y is greater than. What? Yeah, right. Are you sure? That affects like whether you have a solid or dashed line, but the shading doesn't make a difference for that.
Well, I'm saying like the shaded region applies to one.
Correct.
Does y apply to the solid dash?
No. Yeah, that doesn't matter.
The sign of the problem compared to
Yeah.
the sign of the line.
Like you would know in the very beginning of your problem whether you have a solid or a dashed line before you did anything.
When you solve it, you see what your answer is.
Correct. Yeah, correct. Okay. So let's look at just graphing like these two lines, okay? Now, the first one you have to put into slope intercept form, which is y equals mx plus b. In this case, it would be y is greater than or y is less than or equal to mx plus b. We get a lot of people who just say, oh, well, the slope is 1 and the y-intercept is 8 because 1 is next to x and 8 is by itself. But you have to solve for y first. So what would your first step here? And I'm going to suggest getting y on the left-hand side. It's not that it's impossible if you get y on the right-hand side, but it does make it easier if it's y is on the left-hand side. So what would you do first here? So yeah, subtract x. So you get negative y is greater than or equal to negative x plus 8. And then what? Divide by negative 1 or multiply by negative 1. What happens when you do this? It would be a solid line, yes. The sign flips. Why does this sign flip? Because I divided by the negative. So I get y is less than or equal to negative x divided by negative 1 is going to be just x. And 8 divided by negative 1 is negative 8. So my y-intercept is negative 8. And what is my slope? 1, right? It's the number that's right next to x, the coefficient with x. So my slope, because there's not a number there, I don't have to show 1x. So my slope is 1. So from my y-intercept, I'm going to go up 1 to the right 1. And Xander said the line's going to be solid. How did he know that before I even had it graph or before I even solved it? Yeah, because it's greater than or equal to. That line underneath shows me that it's going to be a solid line. So I'm going to connect it as a solid line. Now, when I did solve this, I got y is less than or equal to. I'm going to write that out in words. You have to, I don't think we're going to say how many points, but I would make sure that I had at least 3. Okay. So this says y is less than or equal to x minus 8. So since y is less than, I'm going to shade below my line. So it goes to any point, then I'm shading below that line. That's what I'm going to shade, is this section here, because it's below. All the y values are less than or equal to x minus 8. So there's 3 steps. You got to graph your line. You got to decide if it's solid or dotted, and you got to shade. So So let's do this next one. X is greater than -4. So just as like a reminder, okay, when you've got X is equal to something, is that a horizontal or a vertical line? Vertical, which means it go like this. And if I have Y equals something, that's going to be a horizontal line. So if you don't remember that, right, it's Y. If I had X equals -4, okay, all of my X values are -4. So I would plot the point like -4, 0, -4, 1, -4, 2, etc. Okay. Is this one going to be solid or dotted? Dotted, right? Dotted or dashed. Because there's no equal to underneath it. So we have this. And if you were just to like take a guess here, right? I've got X is greater than -4. Do you think the greater than values are to the left or to the right? To the right, right? So all of the greater than values are over here. That's what we're going to shade. And that makes sense, right? Like a number that's greater than -4 is 0 or 10 or 2. And all of those X values are shaded here. Okay. Questions on these two? So that's just linear inequalities. Can you ladies stop talking back there, please? Thank you. So this is a system. What makes this different? Why is this a system? Yes, it's 2. So this first equation, if I graph this one's easy because it's already in slope-intercept form. What's my y-intercept here? -1. And what's my slope? 1/3. So I'm going to go up 1, to the right 3. Up 1, 3. Up 1, 3. Now, is this going to be solid or dashed? Yeah, dashed. Make sure we can tell it's dashed. Some people like get real stressed out about that and they write like dashed next to it. That's fine. So this wants the y values that are greater than this line. So I'm going to shade above it. Now I'm going to have more than one. My solution is going to be where they overlap. So I'm going to just kind of draw this. I'm not going to shade the whole thing in because especially if you're like a dark writer or a dark shader, it gets really difficult to figure out where they overlapped each other. This second equation, though, is not in slope-intercept form, so I need to solve for y. What's my first step here to solving for y? Subtract 5x. So I get -3y greater than or equal to -5x minus 9. Then what? Divide by -3. Now I have to divide everything by -3. Don't forget that. So when I divide everything by -3, what happens to my inequality when I divide by a negative? Switches. So I get y is less than or equal to, what's -5 divided by -3? 5/3 x. And what's -9 divided by -3? So +3. Good. It would be yeah, the negatives cancel. Okay. So my y-intercept here is going to be at 3. And my slope is 5/3. So from my y-intercept, I'm going to go up 5 and then to the right 3. Yeah, so with because it's y is greater than that line. So I'm going to shade above that line. That's yeah, for inequalities you have to say. So I just did I'm doing them separately, almost like they're two problems. Okay. 1, 2, 3, 4, 5. 1, 2, 3. Okay. Now is this line going to be solid or dotted? Solid. Good. Okay. And I ended up with y is less than or equal to. So I'm going to shade above or below. Below. So some people only like to shade the end result. That's fine. Your answer is where they overlap, and we need to make sure that you know that. So I'm going to shade this section here darker because that's where they overlap so that I know that that's where my answer is. Okay. Some people they point to it and they say that that's their solutions. That's fine, whatever it is. As long as I can tell that you know where it is, that's fine. So some people only shade the solution. That's fine. Some people shade both and then they point to it. It's fine. Some people just make it darker. It's an infinite number of solutions. It's any point that's in there. They do, but actually that point there isn't a solution. Does anybody know why? It's a good question. Does anybody know why this point here is? Because it's on a dashed line. That's right. It's not a solution. Good question. So the solution for two just linear equations is where they intersect. This, when we're talking about linear inequalities, it's where all of their solutions overlap. Okay. Does this question? Whoops, what happened there?
That would be like staircase.
No, but it's kind of in like the same way that it's gonna be straight lines, right? No, it's not gonna look like a bar graph. What's this first one? Is this gonna be a horizontal or a vertical line? Vertical. Solid or dashed? Dashed, okay. And is it gonna be to the right or to the left that I shade? To the right, okay. What about y is greater than or equal to -2? Is that gonna be a vertical or horizontal line? Horizontal. And it's solid because it's greater than or equal to. So now I'm shading above. So I know that where they intersect, right, so far is in this box right here. And you can shade the whole thing. I just know that my final solution is going to be somewhere in there. What about, I'm just going to skip to this. X is less than or equal to 8. Is that vertical or horizontal? Vertical. And it's dotted. Okay. And I would shade to the left. So far I'm right here. Now, this one here, y is less than x. That one's a little bit different. Why is that one different? I didn't ask if it was horizontal or vertical anymore. It's diagonal. Okay. Where's the y-intercept here? And what's the slope? 1. Because this is like 1x plus 0. So if that helps. So my y-intercept's 0. And this has a slope of 1. And it's dashed. And it's y is less than x. So am I going to shade above or below that line? Below. So now I can tell that my answer, my solutions, is going to be in this box right here. So kind of like a bar graph. It's like one bar, but kind of. Questions there? Okay. All right, writing linear inequalities. So we're going to start with y here, okay? And do you think that this is y is greater than or y is less than? Greater than, right? It's shaded above the line. So it's greater than. Is it going to be greater than or greater than or equal to? Greater than, because y. Dash. Okay. So now this part is just mx plus b. So what's my kind of, well, I haven't finished it, but it'll be something like that. So my y-intercept here is 1, 2, 3, 4. So minus